Hello everyone and welcome to a new session presented to you by PyLeasing Channel. PyLeasing Channel is dedicated to serve you with the best learning content and experience in mathematics. Today's session we will be talking about the set notation. We all know that the set is a collection of objects or things. A set is represented by a capital letter A or B or C or whatever. Okay, so A contains a certain number of elements. These elements or members can be of common type, common features. Let's say we have even numbers 2, 4, 6, they share a common property. And let's say B is another set that contains the following 3, 5, 7, 9, as it may seem, they are odd numbers. Okay, so first of all, we need to know what's the number of population elements in A. We say n of A, okay, which is equal to number of A is gonna be 4 elements, 4 members. Number of B is gonna give me also 4 members. Okay, so we say that n is the number of elements in A, n is the number of elements of B. Okay, this gives us the how many elements are there in that population. Okay, now we will speak about a certain symbol mostly used in the relationship between an element. If I want to relate an element to a set, we say belongs to. An element belongs to a set or is not in that set, does not belong to. Okay, so let's take an example. Look at 4 and compare it to the elements that are located in A. Is 4 located in A? Yes, it is. So I would say that 4 belongs to A. Check 5. Is 5 an element in A? No, it is not. 5 is an odd number. So we would say that 5 is not an element of A or does not belong. Another symbol is usually used in set notation is the subset. When we are speaking about subset, we speak about sets regarding sets with respect to other sets, or is a set subset of another one or not. So the relationship now is between a set and another set. Let's say I have a set, name it F. F is equal to 2 and 3. It only contains 2 and 3. Now F, is it in A? Are the elements of F all in A? No, they are not. So we say it's not subset. Let's take another set, call it E. E, it has, let's take for example 2 and 4. Is E, the set E, a subset of A? We will check the elements of E. Yes, I can see that 2 and 4, both of them are in both sets. So we see that E is actually subset of A. Okay, so so far we have talked about the set notation, we have talked about the number of elements in a set, and now we will check out another notation which helps us understand how things are going on. Okay, now let's delete these. I think this is simply set. Okay, let's take something called a universal set. Universal set is the main set of a certain exercise we want to talk about it. Let's say we have U, the universal set that goes from numbers from 1, 2, 3, it continues till it reaches 19. This is an example. I did not write the 4, the 5, the 6. We know intrinsically that these numbers are actually in this universal set. Okay, so we took this set, which is the universal set. We call it the universal set. It's like the universe. Okay, so this is the universal set. This is a very small universal set, by the way. Some sets are infinite, some sets are finite. So this set is basically a finite set. So far we take as a finite set. Let's take an example for another one and we check how we can relate these. Okay, let's take an example of a set P is, let's say, contains 1, 2, 3, 4, 5 and ends here. Q contains, let's say, 6, 7, 8, and it ends at 19. As we may see, that P is a subset of the universal set. All elements of P are included in U, and Q is also subset of U. Okay, so basically I can see that both of them together is going to give me the set U. Union, later on we will talk about that. Okay, now we will talk about the complement of P, the complement of P, where it's the complement of P in the universal set. What does it mean? It means what are the elements of P that what are the elements of U that are not in P? It complements the P set, so I will see that it goes from 6, 7, and until 19, which is actually giving us Q. Similarly, if I want the complement of Q in the universal set, it's gonna give me 1, 2, 3 till 5, okay? So this is the complement of set P, okay? The complement, what completes it. Okay, is it clear? That's great. Now we will speak about the empty set is denoted by phi. Phi means a set of empty elements. It doesn't have any element. We are presented by the two ways, the braces or the phi set. Okay, now with this will end for us this session. Thank you so much for watching. Stay tuned. Feel free to invite your friends to subscribe, to like, to share, whatever, and have a great day.